Lesson 27, Mechanical Power. In this lesson, we are actually going back to our topic of mechanics. Our objectives are to be able to define power, to calculate the mechanical power using the definition of power. So to start off with, our definition of power. And power is the rate at which work is done or energy is expended. So remember, if it's a rate, we're taking whatever and dividing by time. In this case, our whatever is we're counting work or energy over time. The symbol that we're going to use to represent power is a capital letter P. And although we have already used a capital letter P for pressure, the formulas for pressure and power are going to be very different and involve very different things, so you shouldn't get them confused. Our formula is relatively straightforward and comes right from our definition. Since power is the rate at which work is done, our whatever is work, which goes on top, and time goes on the bottom. You're going to want to put this formula on your formula card under mechanics. Now, you're only going to be solving for the power. You don't have to worry about solving for the work or the time, so you don't have to worry about putting this into a triangle. Our unit for power comes out of this formula. It's a derived unit. Since work is measured in joules and time is measured in seconds, we get a joule per second. And much like some other units that you've seen already, like the Newton meter, which is a joule, and the Newton per meter squared, which is a Pascal, a joule per second has another name. It's called a watt, and it's abbreviated also as a capital letter W. Now you shouldn't get this confused with work, because the symbol W for work is going to be in a formula. The W for watt is always going to appear after a number. So a joule per second and a watt are the same thing. In the British system, our unit of power is called the horsepower. It's abbreviated as HP. Now, something that can be a little confusing is the term kilowatt hour. Because it has the term watt in it, we tend to think that it's a power unit. As it turns out, a kilowatt hour is actually a unit of work or energy. And the reason is this. If we were to rearrange our formula for power to solve for work, work is the power times the time. Kilowatt would be 1,000 watts. Time would be hours. So we're taking kilowatts times hours and getting a kilowatt hour, a unit of work or energy that's supplied. So when you see this unit, you don't want to get confused and think that this unit is a unit of power. It's actually work or energy. Now let's try an example. How much power is required to produce 5 joules of work for 10 seconds? So as usual, we start by identifying what we're looking for. How much power? We could put down our formula for power, which is work over time, which means we need work and we need time. So it tells us we have 5 joules of work and 10 seconds for time. We could substitute those values in along with the units. 5 divided by 10 gives us 0.5. And then our unit comes right out of this. We have joules over seconds, so we get joules per second, which remember is the same thing as a watt. So our answer is 0.5 watts.